So this video is on measuring voltage in DC circuits, and it's covered in chapter 29.1 of the textbook. Okay, so how exactly do you measure voltage or potential difference in a circuit? Well, typically you would use something called a voltmeter or a multimeter, which can also function as other things, but you're treating it as a voltmeter. And the key thing to remember is if you're measuring voltage or potential difference, the voltmeter should be connected in parallel to the circuit element you want the potential difference across. So, and by convention, so voltmeters, they typically have a red lead and a black lead. So the convention is the red lead goes on the high potential side and the black lead is on the low potential side. And again, the way to remember that, so we like to think in terms of what's called the conventional current. So the conventional current means we're pretending that it's positive charges that are moving around the circuit, even though it's really the negative electrons traveling in the opposite direction. But if we use conventional current, we imagine the positive charges are moving, so you can think of it as the positives are coming out of the positive terminal of the battery or your EMF device and coming back into the negative terminal of the EMF device. So the voltage, or the potential difference, delta V, is the difference, so the potential measured on the red lead minus the potential measured on the black lead. Okay, so there's some rules, and these are all based on Ohm's law. So for wires, so for our class, we're always going to assume that we have ideal wires. So the resistance of the wires is going to be 0. So the potential difference across any wire is going to be 0. So there's no potential drop across the wires. For resistors, of course, there is a drop in potential across a resistor, and it's just given by Ohm's law. So the potential difference across a resistor, again, is going to be minus I times R. So the negative sign means you're losing potential through the resistor. So a switch, well, closed switches just act like wires, so there's no potential drop. But if you have an open switch, there could be a potential difference between the terminals on your switch. So the EMF rule, again, for ideal EMF devices, says that there's a gain in potential equal to the terminal voltage. And we'll talk a little bit about non-ideal EMF devices also. So potential difference is just the terminal voltage. And if you have circuit elements in series, so remember series means one after the other, so the potential difference is just the sum of the potential differences across each circuit element. So if you have two batteries connected together in series, then the total gain in potential is just going to be the sum of the gains from the two batteries. So and here's some pictures to illustrate this. So again, if you have a wire, so for ideal wires, there is no potential drop across the wire for a resistor or a light bulb in this case. You get a drop in potential equal to negative I times R. And again, a closed switch acts like a wire, so no difference in potential. Open switches, there can be a difference in potential. And for your EMF device, ideal EMF device, so the difference in potential is just the terminal voltage.